Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're wrapping up our season on Java version comparisons. We've covered a lot of ground from Java 6 all the way to Java 22, and now it's time to tie it all together. Joining me, as always, is our Java expert, Victor. Hey, Victor, are you ready to summarize this journey through Java's evolution?
Absolutely, Sheila. It's been quite a ride through Java's history, and I'm excited to help our listeners consolidate everything we've learned. Before we dive in, I think it's worth noting that understanding Java's version progression is crucial for any serious Java developer. It not only helps in writing more efficient code, but also in making informed decisions about which features to use in different projects.
Couldn't agree more, Victor. And speaking of informed decisions, let's kick things off with a quiz question for our listeners. Here goes. Which Java version introduced the revolutionary var keyword for local variable type inference, significantly reducing boilerplate code?
Oh, that's an excellent question, Sheila. It really hits on one of the most impactful changes in Java's recent history. The introduction of the var keyword was a game changer for many developers. It's interesting to consider how such a small addition could have such a big impact on code readability and developer productivity. I'm curious to see how many of our listeners can pinpoint the exact version that brought this feature.
Indeed, it's these seemingly small changes that often have the biggest impact. Now, before we dive into our summary, let's quickly refresh our listeners on some key terms. Victor, could you give us a quick rundown of what we mean by terms like LTS and JEP in the context of Java versions?
Certainly, Sheila. LTS stands for long-term support. These are Java versions that receive extended support and updates, typically for several years. They're crucial for enterprise applications that need stability and long-term maintenance. JEP, on the other hand, stands for JDK Enhancement Proposal. It's the process by which new features and major changes are proposed and implemented in Java. Understanding these terms helps in grasping the significance of different Java releases.
Thanks, Victor. That's a great foundation for our discussion. Now, let's start our journey through Java's evolution. Can you give us a high-level overview of how Java has changed from version 6 to the latest releases?
Absolutely. Java has come a long way since version 6. The most significant shift we've seen is the move towards more functional programming features, improved performance, and better support for modern programming paradigms. Java 8, for instance, was a landmark release with the introduction of lambda expressions and the Stream API. From there, we've seen a steady stream of improvements, from the module system in Java 9 to pattern matching in more recent versions.
That's fascinating. It seems like Java has really adapted to keep up with modern programming needs. Could you highlight some of the major changes in concurrency and performance across these versions?
Certainly. Concurrency has been a major focus area. Java 7 introduced the fork-join framework, which was a big step forward for parallel processing. Java 8's completable future was another game-changer, making asynchronous programming much more accessible. In terms of performance, we've seen significant improvements in garbage collection, with the introduction of the G1 collector in Java 7 and ZGC in Java 11. The JVM itself has become more intelligent with each version, offering better runtime optimizations.
That's quite a progression. Now, I'm curious about the new features and APIs. What would you say are some of the most impactful additions we've seen across these versions?
Great question, Sheila. There have been so many, but I'll highlight a few. The Stream API in Java 8 revolutionized how we process collections. The module system in Java 9 improved application security and performance. Records in Java 14 simplified data classes. And more recently, we've seen pattern matching for switch statements, which is making code more expressive and less error-prone. Each of these features has had a significant impact on how Java developers write code.
It's amazing to see how much Java has evolved. Victor, in your opinion, what has been the overall impact of these changes on Java development?
The impact has been profound, Sheila. Java has managed to stay relevant and powerful in a rapidly changing tech landscape. These updates have made Java more concise, more performant, and better suited to modern application development. We're seeing Java used in everything from traditional enterprise applications to cutting-edge machine learning projects. The language's ability to evolve while maintaining backwards compatibility has been crucial to its continued success.
That's a great point about backwards compatibility. It reminds me of an interesting anecdote. Did you know that when Java 8 was released with lambda expressions, there was concern about how it would affect existing code bases? But the Java team managed to implement it in a way that didn't break existing code. It's a testament to their commitment to evolution without disruption.
Absolutely, Sheila. That's one of the things that makes Java special. It's not easy to add major features like lambdas without breaking existing code, but the Java team pulled it off. It's a great example of how careful design can allow for significant improvements while still maintaining stability.
Now, as we wrap up, let's address some common misunderstandings. Victor, what's a common pitfall you see developers fall into when dealing with different Java versions?
One common issue I see is developers jumping to use the latest features without considering the target environment. For example, using var or text blocks in a project that needs to run on Java 8. It's crucial to understand your deployment environment and choose the appropriate Java version and features. Another pitfall is not taking advantage of new features that could significantly improve code quality or performance simply because developers are used to the old ways of doing things.
Those are great points, Victor. Any final tips for our listeners on staying up to date with Java versions?
Absolutely. I'd recommend regularly reading the JEP index to see what's coming in future versions. Experimenting with early access builds can also be helpful. And of course, following reputable Java blogs and attending conferences can keep you informed about best practices and real-world applications of new features.
Excellent advice, Victor. Now, it's time to reveal the answer to our quiz question. The var keyword for local variable type inference was introduced in Java 10. This feature has indeed made Java code more concise and readable.
That's right, Sheila. And it's a perfect example of how even small changes can have a big impact on day-to-day coding.
Absolutely. As we conclude this episode and our season on Java version comparisons, let's summarize the key points. Point 1. Java has evolved significantly from version 6 to 22, focusing on functional programming, improved performance, and modern programming paradigms. Point 2. Major improvements in concurrency and performance have been made, including the fork-join framework, completable future, and advanced garbage collectors. Point 3. Key features like lambda expressions, the Stream API, the module system, and records have revolutionized Java development. Point 4. Java's commitment to backwards compatibility has allowed for significant evolution without disrupting existing code bases. Point 5. Staying informed about Java versions and carefully considering your project's needs is crucial for effective Java development. Victor, any final thoughts?
Just that it's an exciting time to be a Java developer. The language continues to evolve and improve, and I'm looking forward to seeing what future versions will bring. Remember, the goal isn't just to use the latest features, but to write better, more efficient, and more maintainable code.
Well said, Victor. And that wraps up our season on Java version comparisons. Next season, we'll be diving into some advanced Java topics, so stay tuned. If you've enjoyed this series, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue providing in-depth Java knowledge. Until next time, happy coding.